Okay, let's say you were to heat a sample. Okay, what did we say happens to the entropy? Increases, right? And that's because at a higher temperature, you have more thermal energy. That's higher entropy. We already talked about that. What about if you're expanding at constant temperature and pressure? Okay? What happens if something expands? Let's just say constant temperature. Okay? So let's say I have, for example, a gas in here. Okay? And I were to open up this box right here. What happens to my gas? It spreads out, right? It fills the entire container. By increasing the volume, what am I doing? I'm giving my molecules more freedom of movement, okay? So the allowed energies that they can have, the spacings between the allowed energies they can have get smaller. Okay, so we say the quantization of energy gets smaller, so you have smaller gaps between allowed energy levels, so you have more ways of distributing the same energy, provided they have the same thermal energy. So you have to look, when you look at these things, you look at either increasing thermal energy, or you look at the situation where the thermal energy remains the same, and in those cases you just say, are we going into a situation where there is more freedom of movement for the atoms, less restrictions on the movement, then those would lead to higher entropy. Okay? And so if there's more freedom of movement, you say, we associate that with the notion of greater disorder. You might have encountered entropy in other courses, and you've been taught that it is a measure of disorder. That's actually only looking at one side of the picture. Okay, it's really a measure of how many ways you can distribute the thermal energy. And one way you can increase the ways of distributing the thermal energy is if you have more disorder, greater freedom of movement. Okay? So let's look at phase changes at constant temperature and pressure. Going from a solid to a liquid, like if you're melting ice, solid to liquid. What did we say entropy for that one? Does it increase or decrease? Delta S was just delta H over T, right? And that's a positive number. We, we had that example earlier for heat, for the entropy of fusion of ice. Entropy increases. Why? As you're going from a solid water to liquid water, what happens? Atoms are more free to move in, the molecules are more free to move in the liquid. So that's a higher entropy. Liquid to gas, same thing, right? There's more freedom of movement in the gas than in the liquid. Solid to gas, that also increases entropy. So for all of this, delta S is positive. You have the same thermal energy, okay? All right? And so the energy you're putting in is used by the molecules to overcome the forces of attraction among them. So you have more freedom of movement, you get closer energy spacings, and you have higher entropy. What if you're looking at reactions? If you're asked to predict the delta S for the reaction, you're being asked to compare the entropy of the products versus the entropy of the reactants at the same temperature. Okay? So what happens in a reaction? The more gas molecules or simpler molecules you're making in your product side, okay, then that means they'll have more freedom of movement, and you'll look at closer energy spacings that would lead to higher entropy. So let's take a look at a few questions here that illustrate these concepts. What's the entropy change for heating water from 25 degrees to 75 degrees? Is it positive or negative, A or B? This should be easy. Positive, right? Entropy increases. Delta S is positive. You have an ideal gas at 298 K 1 atmosphere. Okay, you lower its pressure to half atmosphere at the same temperature, so same thermal energy, okay, but you lower the pressure. What happens when you lower the pressure? Which law is applicable here? Boyle's law? P1 V1 equals P2, V2, right? At the same temp, at constant temperature, pressure and volume are inversely proportional. So what happens if you lower the pressure? So if pressure goes down, according to Boyle's law, what happens to the volume? Volume goes up. So will the entropy A increase or B decrease for this process? Correct answer? Increase. Why increase? Volume expands, more room to move about. So greater disorder. Okay? Solid turning into a liquid, constant temperature. That's melting of ice. Delta S is positive or negative? Positive, right? Just talked about that. Next one. You have N2 plus 3H2 gives you 2NH3. Will this lead to an increase in entropy or a decrease in entropy? In other words, is delta S going to be positive or is it going to be negative? Constant temperature, looking at the same thermal energy for products and reactants. You're only going to compare this time the freedom of movement, right? The quantization of energy. Are you more restricted now or are you less restricted when you convert your nitrogen and H2 to NH3? Let's see. Negative. In fact, we calculated that earlier to be negative, right? So why is it negative? You have 4 moles of gas here versus 2 moles of gas. Okay? You have simpler molecules here. Your nitrogen and hydrogen are diatomic, whereas your molecule of ammonia is a polyatomic molecule. So there's more restrictions on the movements of the atoms in NH3. So from simpler molecules would be associated with higher entropy. So you go from simpler molecules to more complex molecules, that would lead to a drop in entropy. Okay? Entropy change for this, increase or decrease? Is it going to be positive entropy change or a negative entropy change? Calcium carbonate solid gives you calcium oxide solid plus CO2 gas. Increase entropy, more freedom of movement here, okay, because of that gas that's formed.